G'day guys, we've got an applications of integration question here today where it says the marginal cost for producing X hundred units of a product is given by this function here, where C is the cost of producing X hundred items of the product. Find the cost of producing 100 of these items if the fixed cost is $2,000. Okay, so these are quite simple questions. What we can do here is the beauty of calculus is that we can work quite freely between differentiation and integration. So what we can do, just like to cancel out the denominator of a particular fraction, we can multiply by that denominator. To cancel out or move back from the derivative or gradient function to the regular function, we can just integrate it. So what we're going to do is we're going to say that the cost function, or C, will be equal to the integral of dc dx dx, which is equal to, so this is an indefinite integral, so what we're going to have is this is the integral of 0.08x, let's put it in a bracket to make it easier to see, dx. Now from here we just take the integral. Now I'm hoping that you guys know how the mechanics of an integral works. So what we're going to do is we're going to raise this x to the next power up, so it's going to be x squared, and when we divide the coefficient by the new power. So 0.08 divided by 2 is 0.04 x to the power of 2 plus, we always have to, for indefinite integrals, we always have to put our plus c term on the end. So what we do, we're lucky that they've told us that the fixed cost, or for this one, so this is the fixed cost when, so this is when x equals 0, is $2,000. So we can say that the fixed cost, or the y-intercept, when x equals 0 is $2,000. So hence, we can use this to say that C will equal $2,000. So what we're going to do is we're going to put that into our function here, and we're going to have 0.04x squared plus $2,000. Now this is our cost function, so cost. So what we then do is to find the cost of producing 100 items. Because we actually have our cost function now, we just evaluate this when x equals 100. So we substitute in 100 and we get 0.04 times 100 to the power of 2 plus $2,000. Now 100 squared is 10,000. 4% of 10,000 is $400. So we're going to go $400 plus the fixed cost of 2,000 is going to give us a total cost of 2,400. So that's the solution to our first problem. Now on to part B. Find the net change in costs if the number of items produced is changed from 1,000 to 2,000. Okay, because we've got net change in cost here, the fixed costs in this part of the question don't really make any difference because, for example, if we've got a function, let me draw some axes. If we've got a function that say looks like this, and we're looking for the net change in y from when we've got x equals this value to x equals this value. Now, I don't know if you're aware, but if you have a look at this, we're looking for the change between this point and this point. So these 2 points could be located down here we're just looking for the difference in between them. We don't really care where they're actually located. All we're looking for is this value here. So the C value is not really that important to us. Now that's our justification for using this method to solve it. So find the net change. We're going to go the net change will be equal to the integral from 1000 to 2000 of the marginal cost function. So dc dx, and what we get is this is going to be equal to 0.04 times by 2000 squared, subtract 0.04 times by 1000 squared. Now this, if we evaluate it, is going to be, what is that? That's 4 million times that. So that's going to be 160,000. Subtract a million for 40 grand. So we find our net change to be equal to 160, take 40, is equal to $120,000. So you can see basically with these net change questions, they're going to be exploiting or trying to ask you to exploit your knowledge of the various linkages between differentiation and integration. So you must be able to move backwards and forwards in differentiation and be comfortable doing it. But once you've done that, these problems here don't take very long to do at all, and you should, by the end of your school year when you're getting ready to sit exams, these are the kind of questions that I would have said that probably these are where I'd be trying to get all my marks from. I could guarantee that I'd get the marks for this one. So I hope this video helped. If it did, chuck us a like, do us a favour, subscribe to my channel, ask me a question. I'm always looking for new problems to solve. So until next time, catch you later.